Here in chapter 7, we're talking about the triangle midsegment and triangle inequalities. So when we look at this midsegment, a midsegment is a segment connecting the midpoints of two sides of a triangle. Okay, a midsegment is a segment connecting two sides of a triangle, of the midpoints. So when we look here, if I say this is a midpoint here, this is a midpoint here, I connect those, this would be the mid-segment of those two sides. Okay? Now, when we look at this, the triangle mid-segment theorem simply tells me that you know that it is parallel to the side that does not intersect, as well as half the length of the parallel side. So I know that DE is parallel to AC. Okay? I also know some relationships. I know that DE is equal to 1/2 of AC, or I also know that 2DE is equal to the full length of AC. Okay? So, how does that help me? Well, if I look here, I know AC is a midsegment. They tell me that A is a midpoint, B is a midpoint, and C is a midpoint. And they tell me that AC is 3/2 x plus 5. They also tell me that AB is 4y plus 1. They tell me HJ, so the full segment here, is 8x plus 5. And they tell me that GJ, the full segment here, is 4y plus 18. Okay, so what relationships do I know? Well, I know that AC is parallel to HJ. That means that 2 times 3/2 x plus 5, that is going to equal the full length of HJ. So then if I distribute my 2 in, I get 3x plus 10 equals 8x plus 5. I minus the 3x, and then I minus the 5. So I know x must equal 1. Okay? Then on the second one over here, I know that AB is parallel to GJ. So again, what do I know? I know that AB, 4y plus 1, is equal to half of 4y plus 18. Now, or you could do 2 times 4y plus 1 equals 4y plus 18. Either one will get you the same answer. So if we distribute that, we get 4y plus 1 equals 2y plus 9. I'm going to minus the 2y. I'm going to minus the 1. So y must equal 4. But be careful here, because what they're asking for is the measurement of CJ. Now remember, CJ is half, because C is the midpoint, half of the length of GJ. So if I plug the 4 in, I know that I'm going to equal half of GJ. So that's going to give me 1/2 of 4 times 4 plus 18. So that will be half of 16 plus 18 is 34. So that means that CJ must equal 17. Okay, so that's how we use that. Now, let's go over the longer side theorem. It says if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So what does that help us do then? Well, if I look here, I know that 24 is the smallest. So what that means is angle L has to be the smallest. I also know that 32 is the biggest. So that tells me angle K has to be the biggest. Okay, so if I wanted to write that into an inequality, I know that the measure of angle L has to be less than, the one in the middle here is going to be measure of angle J, who has to be less than the measure of angle K. Okay, all because they have to be opposite of the longer is the largest angle, smallest is opposite of the smallest angle. We also can go the other way. So if one angle of a triangle is larger than another angle, then the side opposite the larger angle is equal to the side opposite of the larger angle. The smallest angle is opposite of the smaller side, and so on and so forth. So when we look at these, what we know is just by doing a little basic math, we know this angle has to be 82 degrees. So therefore, when I look at this, I know 47 is the smallest. And then I also know 82 is the biggest. And then we know 51 has to be somewhere in the middle. So if we write that out then, I know that DF has to be less than FE, which has to be less than DE. Okay? So that's how we use that to our usage. Last one, we have triangle inequality theorem. The sum of any two sides of a triangle must be greater than the third side. Meaning if I take any two sides, add them together, they have to be a value greater than the third side. So, can these measurements form a triangle? Well, the thing is the nice thing is you only have to test one thing. Because here, 10's the biggest. 10's already bigger than 9. 10's already bigger than 4. So if we added anything to 10, it's definitely going to be bigger than those. So all we have to test is the one of the two smallest adding to be bigger than the biggest. So does 4 plus 9, is that greater than 10? And yes, that is. So therefore, that could be a triangle. Is 8 plus 9 greater than 18? And that answer would be no. So that cannot be a triangle. So then we look here, we have 5 plus 7. Are you bigger than 12? And again, that answer is no, because that is equal to 12, but it is not greater than. Okay. Now on this last part, it says, given two triangle side lengths, what's the range of possible lengths for the remaining side? Okay, so the first one, let's assume that the third side is the biggest side, and we haven't gotten to it yet. So if that's the case, if I take 9 plus 14, that is 23. So by the rule, the triangle inequality theorem, we know that 23 has to be bigger than x. We don't know what that x is. Well, likewise, then if you look at this combination, you know 9 plus x must be bigger than 14 if we assume 14 is the biggest. Well, that would, by solving that, we would know that x would have to be bigger than 5. So our inequality comes out to say 5 is less than x, less than 23. Okay, we can do very similar. So if we assume the third angle is going to be bigger, if we add those two together, 12 plus 20, that gives us 32. So we know that third angle, x, has to be less than 32. Likewise, if I know that 12 plus x has to be bigger than 20, then I know x also has to be bigger than 8. And that would be our inequality, giving our possible range of values for the third side.